This is 8 Minutes, a podcast helping you understand the energy and climate challenge in just a few minutes. I'm your host, Paul Schuster. About 50% of the world's energy usage goes towards heating and cooling, and a huge chunk of that heating component is in really high temperature applications. Industries like steel, concrete, petrochemicals, plastics, even food production that require a lot of energy. These are typically referred to as hard-to-abate industries, as decarbonizing them may require really transformational technologies. Or do they? An emerging set of startups are finding really interesting ways to electrify those industrial processes through thermal storage batteries. And maybe 95% of our industrial processes could be handled by these technologies. Today, let's dig into what these systems do and how they may turn hard-to-abate on its head. 8 minutes. It's how long it takes the sun's rays to hit Earth, or about the amount of time it takes to eat way too many holiday sugar cookies. I know from experience. Let's get it on. A lot of the technology that we need to decarbonize society is already available and relatively mature. Wind turbines, solar power, heat pumps, EVs. But there remains a class of applications that still require fossil fuels, namely large industrial heating used for industries such as cement manufacturing or steel production or, well, just about any of the manufacturing that makes the stuff that we use. McKinsey estimates that only about 20% of the energy used in industrial applications today is currently from electricity. So, what's needed to move that number higher? Can electricity really play a role in high heat environments, or how else can these processes decarbonize? The perhaps surprising answer is that we've only just tapped the potential of electricity for industry. But over the past few years, a host of startups have sprouted up aimed at bringing renewable power to industrial uses. Let's first start, though, with realizing that not every industrial application is the same. There's a wide range of temperature requirements depending on whether you're forging steel or baking a series of Oreo cookies. That same McKinsey study that I cited earlier estimates that about 50% of industrial processes require heat up to about 1,000 degrees Fahrenheit. About 20% require temperatures between 1,000 and 1,800 degrees, and then 30% of applications require the really extreme temperatures. That 30% may be a stretch for today's technologies, but that's where carbon capture and hydrogen are showing promise to help decarbonize high heat applications. The processes under 1,000 degrees, though, are ripe for electricity-based solutions. In fact, a good chunk of those processes are actually steam applications. In fact, steam is the most widely used form of heat transfer fluid used today, and many industrial processes use either natural gas or fuel oil or some other form of fossil fuel source to power their steam boilers. Converting those steam boilers to electric is honestly relatively straightforward. Atmos Zero, for instance, provides drop-in air-sourced heat pumps for industrial applications. Those units replace the fossil fuel boiler and are capable of delivering carbon-neutral steam at up to about 400 degrees Fahrenheit. And heat pumps are remarkably efficient at converting electricity into heat. A coefficient of performance of 2 for a heat pump means that an industrial application is getting 2 units of heat for every 1 unit of electricity being used. But higher temperature applications require a different solution. And, well, we need to start to consider how electricity is being consumed too. Because just converting electricity to heat isn't enough. We can do that with resistance heat or some other form of on-demand application. But if we're focused on decarbonizing the industrial process, we need to ensure that the electricity is coming from renewable energy sources, which, as we all know, are intermittent and, well, the access to wind power may not align exactly with the moment when you're trying to access that high temperature heat, which is why thermal batteries are becoming so interesting in the market right now. These units are not very complicated. We've been heating and cooling bricks and stones for centuries, and essentially that's all we're doing with these thermal batteries too. We use electricity to heat them up super hot, and then we extract that heat for our process. That's essentially what Rondo Energy does in their battery systems. They use electric heating elements like you would find in a toaster to heat up a ton of bricks, and then when the heat is needed, they can discharge that heat. Rondo claims that their systems can reach up to 1,800 degrees Fahrenheit, and they've installed up to 2 megawatt-sized batteries capable of handling really big, intense applications. But innovations in materials and technology can take these thermal batteries even further. Electrified Thermal Solutions, based in Massachusetts and coming out of MIT, has created a series of thermal bricks that double as electrical heat exchangers, replacing the need for those toaster elements. And then these bricks interlace with more traditional firebricks to create a three-dimensional array capable of delivering super high heat. Or Antora Energy, which has eschewed traditional brick technology in favor of carbon blocks. While firebricks may be relatively inexpensive, these carbon blocks have the advantage of being able to heat up to remarkable temperatures. An Antora thermal battery can charge up and deliver industrial process heat of up to 2,700 degrees Fahrenheit. Now we're talking. And starting to address those really high temperatures that I alluded to earlier as being harder to abate. But what's interesting here is not the difficulty to generate high temperature heat. Some processes don't require anything more than what a plug and play heat pump can deliver today. And a vast middle swath of applications could rely upon heating and cooling relatively inexpensive firebricks, the way that Rondo or Electrified Thermal Solutions are doing. And then emerging technologies pioneered by companies like Antora are starting to address those really high temperature applications and processes. What that means is that there's a role for electricity even in industrial processes, which will require more renewables, more grid interconnects, more grid storage resources. But the pathway is there. And since industrial processes contribute about 20% of greenhouse gas emissions into the atmosphere, decarbonizing this sector is critically important. And of course, there's a role for hydrogen and carbon capture to play as well, not only at higher temperatures, but in areas where electricity costs may run high or renewables haven't penetrated the grid fast enough. But what's important to realize is that we have the flexibility and options on how to decarbonize industry. These hard-to-abate sectors are becoming easier to get to zero carbon. Lots of great innovations that are likely to revolutionize this space. I'm Paul Schuster, and this has been your 8 Minutes.